Hi, this video is for Algebraic Foundations class. I'm Josh Eggenberger, and this is the first video in the series. We're going to be doing section 1.R.2. Chapter 1, I think R is for review, and then part 2 is where we're picking up in the text, multiplication and division with fractions. And I'm going to go through the problems from one of the practice pre-certified sections. I have 15 problems for this section, but if you want to skip ahead to problem number, if you already did this section, but you had trouble with the word problems, you can skip ahead to problem 12, probably about halfway through. That's a bigger problem and more difficult, but there's only one like that in the certify and practice that I saw, so I'm not going to really emphasize it too much. Anyway, if you've already completed this section, the certify, you really don't need to watch this video, but you might want to, like I said, check out the word problem, but also just make sure you can hear me and make sure you can read what I'm writing. The first problem I had was 1/3 of 1/4. And think of this as we've got 1/4 of something, and we want 1/3 of that. The easy way to translate this into math is to say 1/3 times 1/4, and that is 1/12. That's it. For number 2, it says to write the product in lowest terms, and all the problems are going to say that. They want you to reduce your fractions. Multiplying fractions, let me write the problem down. 8/9 times 2/5. Multiplying fractions is really straightforward. You just multiply the numerators, the tops, and you multiply the denominators, the bottoms, and that's the product, or what you get from multiplying them. But if you can cancel out common factors to reduce the fractions before you multiply, you'll be able to work with smaller numbers, which is a little bit easier. A lot of times a problem that you would need a calculator for, well, if you reduce first, you don't need a calculator. In this case, there's nothing to reduce. 8 and 2 are only divisible by 2, and 5 and 9 are only divisible by 5 and 3. So there are no common factors, so this is just 16/45. Number 3 says 3/7 times 0. We're going to see things like this occasionally in this section and later sections, but multiplying something, no matter what it is, by 0 results in 0. And then for number 4, I've got 45 divided by 37 divided by 45 divided by 37. I'm going to treat this as a division problem of fractions. And dividing by a fraction can be accomplished by multiplying by the reciprocal. So the reciprocal is the flip, and it's the second one that flips. I'm going to leave the first one alone. 45 divided by 37, or 45/37, times the reciprocal, 37 divided by 45. And in this case, there's a 45 upstairs and a 45 downstairs that cancel perfectly. 37 upstairs and 37 downstairs. What's left is nothing, kind of. Not 0, though. When they cancel completely, they leave a 1. So this is 1/1 is what we're left with, but that simplifies to just the number 1. So there's more on this concept of multiplying by the reciprocal in the lesson part. I know the lesson part for this section is several dozen pages, but the concept is really simple. To divide fractions, you multiply by the reciprocal. This next problem is like that also. We're going to start with a division problem. This is number 5. 4 divided by 32 divided by 27 divided by 44. And I pronounce this as divided by, but you can say 4 over 32, or 4 atop 32, or 4 by 32, whatever it is the fraction. It means division. I know 32 doesn't divide evenly into 4, but there is a common factor that we can cancel here. First, though, I'm going to change this division problem into a multiplication problem by multiplying by the reciprocal of the fraction we're dividing by. Now here, I can see some common factors. I'm going to cancel them out here. I'll do a problem later where we completely factor into prime numbers and we can see all the cancellation. But here, 4 and 32 have a common factor of 4, leaving a 1 and an 8, because 8 times 4 is 32. But if I cancel that factor of 4, I've got 1 over 8 here. Also, though, this has a factor of 4, and this has a factor of 4. So if I cancel the factor of 4 from the 44, 44 is 4 times 11, and cancel the factor of 4 from the 8, leaves a 2. All that's left here is 1 times 11 upstairs, 1, 11, the factors left upstairs, and 2 times 27 downstairs. Well, that's 11 over 54. Since I removed all the common factors, there's no further reducing. This is lowest terms. The next one is a little word problem. So number 6 is a small word problem. It says 4/5 of my books are fiction. Of these, 2/3 are paperback. And the question is, what fraction of my books are fiction and paperback? So, fiction and paperback. Or paperback fiction books. So both in this category of the 4/5 that are fiction, and of these fiction books, 2/3 are paperback. Essentially, we're trying to find what is 2/3 of 4/5. And I'm going to write that down, but then translate it into a math expression. So continuing up here, we're looking for 2/3 of 4/5, and that's like we saw before, 2/3 times 4/5. No common factors at all in these fractions, upstairs or downstairs. So I'm just going to multiply upstairs as 8 and downstairs as 15, and 8/15 of my books are paperback fiction, is what that says. So next I've got another division problem. Division of fractions, so this is number 7. 22/35 divided by 3/4 is 22/35 times 4/3. And there are a lot of these division problems, so you're definitely going to have some of them. That's an important skill for working with fractions. The first step is to make it into a multiplication problem. Then look for common factors. And here, I don't see any common factors. Upstairs, if I factor these numbers, this is 2 times 11, and this is 2 times 2. So my numerator is going to be all that. And my denominator, that's 5 times 7, and then there's a factor of 3. There are no common factors upstairs and downstairs, so I do have to just multiply all these numbers. Now the way you can use a calculator, but it's not going to reduce any further. The one way to see this top part is it's 2 times 2 times 2, that's 8, times 11, or 88. Down here, well, this is the way I do it. 3 times 7 is 21. Well, and then 5 of those. Or use a calculator, but the denominator comes out to 105. And that's the quotient is what you get when you divide something. So the quotient in this case is 88 105ths. Problem 8 has 9/5 divided by 20/16, and I'm doing several of these division problems, even though it's kind of repetitive, but different things come up in different situations. This one, again, I'm going to change it to a multiplication by using the reciprocal here, flip. And then look for common factors, and, well, I see a common factor of 4, because 20 is divisible by 4 and 16 is divisible by 4. That means if I cancel that factor of 4, it leaves a 4 and a 5. And the result here is 9 times 4 over 5 times 5. And there's no common factors. These are only divisible by 2 or 3. And these are only divisible by 5. So that's going to be 9 times 4 is 36. 5 times 5 is 25. And that's our quotient. The next one is also numerical, and I think it's going to be a little bit quicker, though, because we'll be able to cancel some of it quite directly. When I change this into a multiplication problem, 33/10 times 10/27, I can see there's a 10 upstairs and a 10 downstairs, factors of 10 that I can cancel right away. But also factors of 3, both of these are divisible by 3. 33 is 11 times 3, so if I cancel the 3, it leaves if I cancel the 3, it leaves an 11. And 27 is 9 times 3, so if I cancel the 3, it leaves a 9. And what's left here, remember the 10s are factors of 1, if you want to write that. But all that's left upstairs is 11, and all that's left downstairs is 9. 11 times 1 and 9 times 1. 10 says to find the reciprocal of 2/7. And it's kind of math here, but it's really just the understanding this term here. The reciprocal of a fraction is what we get when we flip the fraction. The reciprocal of 2/7 is 7/2, 7 over 2. The reciprocal of a whole number, you can think of that whole number over 1 and do just 1 over that number is the reciprocal. But in this case, it's the flip of the fraction. Here's one that involves a whole number divided by a fraction. And I'm going to do what I just said with the whole number. I'm going to write that as 4 over 1. And then divided by 20/23 is the same as multiplying by 23/20. multiplying by the reciprocal. Now here I can cancel a factor of 4, leaving 1 upstairs and 5 downstairs. 1 times 23 is 23. 1 times 5 is 5. All right. Here's the bad news. This next problem probably won't fit on the board. It's a word problem, and I'm going to write a lot of it out. Just so you'll have, if you want to write it out, you'll have a template for doing your own problems like this. Or you can just watch and try it with one of these problems. And if you have trouble, go back and watch again. There's also a video in the Learn portion. In addition, you can look at the tutor function in the practice sections. I don't think you can use the tutor in the certify part. But if you practice on the practice, the certify is not going to be much different. This is number 12, and I'm going to summarize a little bit rather than write all of the words, but it's a paragraph that they've got here. In this situation, there are 3,600 students, and 1/4 are sophomores. It says this: if 3/5 of, let's call them sophs, for sophomores, if 3/5 of the sophomores are opposed to a climbing club, I think it was a rock climbing club in the original, and 3/4 of the other students are also opposed, then how many students are in favor of the club? So here's kind of the short version of the problem that I got. There are 3,600 students in the school. A quarter of them, or 1/4 of them, are sophomores. 3/5 of the sophomores are opposed to this new club. 3/4 of the rest of the students are opposed to the club. They want us to say how many students are in favor of the club. So I have to erase this to actually do the problem, but there it is. There's the situation, and I broke this into 7 steps to break it into smaller pieces, so I wouldn't have to do big mathematical expressions or complicated ideas. We're going to look at it as 6 little pieces, 7 little pieces, but that come together to give us exactly the answer we're looking for. So, first of all, the number of sophomores. How many sophomores are there? 1/4 of the 3,600 students is 900. There are 900 sophomores, 1/4 of the total 3,600 students. The number of sophomores opposed. So the number of sophomores that are opposed to the rock climbing club, that's 3/5 of the 900 sophomores. 3/5 of the sophomores are opposed to it, and that comes out to 540. That's a good calculator situation. If you want to divide 900 by 5 and then multiply by 3, that's another way that you can get this without a calculator, but either way, it's 540. And then finally, well, not finally, but as far as the sophomores, the number of sophomores in favor of the climbing club. Well, there's 900 altogether, and 500 are not in favor. So 360, and this is what I'm going to come back and use shortly. 360 sophomores are in favor of the club. They want to have the club. Next, I'm going to say number of others, by which I mean not sophomores, so freshmen, juniors, and seniors. So not the sophomores, but just the juniors and seniors and freshmen. That's 3,600 minus the 900 sophomores. And that's 2,700 students, 2,700 students. There's another way that you can find this. The 1/4 of them are sophomores. That means 3/4 of them are not sophomores. You can do 3,600 times 3/4. Same thing. You get the same thing if you subtract the sophomores from the total number. Now, the number of others, right, non-sophomores, opposed. And it says in the problem that 3/4 of the rest of the students are opposed. So 3/4 of 2,700, 3/4 of 2,700 is 2025. And now the number of others in favor I can find by taking the number of others, the total number of non-sophomores, minus the number of the non-sophomores that are opposed. That gives me the number in favor. And that's 675? Yeah, 675. And that, along with this 360, are what I'm going to use to answer the question. It's the number of students. Let's actually say the total number of students in favor of the rock climbing club is 360 plus 675, or 1,035. That's the total number of students in favor of having the rock climbing club. So that was a pretty big problem. I filled up the whole board with the problem itself, and then I did fraction stuff, and I don't know why there's really no intermediate problems. It seems like there's only really quick, short multiplication division problems, and then this kind of stuff. Quite complicated. But the ones that I saw in the Certify and the Practice are very similar to this. So if you can understand this process, you can probably mimic this process to answer those questions. So I've got a couple more, 3 more problems that are kind of the little quick ones. So this one, number 13, is 0 divided by 14/9. And that's, well, if I think of 0 as 0 over 1, I can put it as a fraction. And then divided by 14/9 is the same as multiplied by 9/14. There are no, I don't even need common factors. I multiply upstairs and I get 0. Downstairs is 14, sure, but 0 divided by another number is still 0. If you had the other type of problem where it's something divided by 0, that's where the little undefined bubble comes in. Dividing by 0 doesn't give us a number, doesn't give us a real number, so that's just called undefined. Number 14 is a problem with multiplying fractions, but this time there are 3 fractions. We're going to multiply them all together. You can just do the first 2 and then that result is a fraction and you multiply by the third one. But I think there's a more efficient way to take care of this by, well, there's more numbers here. So I want a way to take care of this kind of all at once. And prime factorization is a great way to do that. I'm going to do that with one fraction at a time. The first one, 8, can be factored into primes as 2 times 2 times 2. That's my, I don't want to write parentheses to group these really. It's just, there's a lot of writing. It's hard to look at anyway. But the denominator, 21, can be factored into 3 times 7. The next fraction, we're going to multiply those numerators. So I'm going to multiply 24, 8 times 3, for example. But if I factor it into primes, it's 2 times 2 times 2 times 3. That is 8 times 3, by the way. There's my 24. Below it, the 9, that's 3 times 3, if I factor it into primes. 33 is 3 times 11, and 12 is 2 times 2 times 3, or 4 times 3. But factored into primes, it's 2 times 2 times 3. Now I'm going to go through all these factors and cancel as many as I can. For example, there's a 2 up here and there's a 2 down here. Well, there's another 2 and another 2. That's all the 2's downstairs, so these other 2's aren't going to cancel. But there are some 3's. There's a 3, and there's a 3, and there's a 3, and there's a 3, and that's it. So I'm going to clean this up. First, I've got 2 times 2 times 2, 4 of them, times 2, times 11, over 7 times 3 times 3. So these are still prime factors, but notice there are no common factors upstairs and downstairs for me to cancel. This is it, and I want to write that number as comes out to well, 7 times 9 is 63. 16. 2 times 2 times 2 times 2 is 16. 4 factors of 2. 16 times 11. 176, I think. I didn't write that down in my solution here, but I think that's correct. And then one last problem. Number 15 was 43 over 40 divided by 43 over 27. And it's that division problem that we're going to turn into a multiplication problem by using the reciprocal. That's 43 40ths times 27 43rds. The 43's cancel. And so I just need to look for common factors in the 27 and the 40. 27 is 3 times 3 times 3. It only has factors of 3 and 9, but that's still made up of 3's. And 40 is 4 times 10. I guess in any case, 40 doesn't have a factor of 3, and 27 only has factors of 3. So those are, you could write them down in prime factored form, but you won't find any common factors. you're going to just multiply them back up to these numbers. That's it for the first video.